Okay, I think that I had already told you guys that here's our homework we'll do, but let's turn to that page 30 and take a look at that problem 28. Okay, so this problem is talking about the data a few pages back. Let's see, here at the bottom of this page when it talked about birth order and then the particular topic you're going into. Okay, page 27. Okay, got it. Thank you, ma'am. And so then here, the first question says, are enrolling in agriculture and human ecology disjoint? Okay, so odds tell the evens what you think, what you know of disjoint, and discuss what you think about that ag and human ecology. So go take a look at that. Go. Okay, so what do we know our definition of those to be? Okay, Heidi, what did you guys come up with? Okay, good. And so based on our picture here, what do you think that human ecology and um, agriculture are disjoint? What do you think, Miss Megan? Okay, so that would be true, but I'm asking about human ecology and I'm asking about this, a person being a human ecology student and a human ecology student in ag. Yeah, I'm asking about. Okay, good. Good. So according to this, you can be disjoint because there's not a person in both. They're either in that ag section or the. Now, technically, we probably don't know that because there are probably some double majors, but I guess we're making an assumption there that typically that's they're not. Okay, so we would say, and you can reference and you can reference that definition. So whenever you do explanations, you always want to reference that definition. So we would say, are they disjoint? And we would say what? Yes. And so you want to reference that definition. That's kind of like the key to get your credit for exams and such assessments. Yes. No student is both in ag and human ecology major. Okay, so the reason that that right there is going to help you is because even if you kind of like disagreed, see, maybe you thought, no, they're not disjoint because there could, and then you could say there could be some students who are human ecology or human ecology and ag, whatever. But your definition would show that you know that definition. Okay, how about this one? Are enrolling in ag and human ecology independent? So that's what we learned yesterday. And because of that, I want to tell you that this word, independent, should be a trigger for you to always think of this. Because that's how we're going to statistically determine if the two events, like we can numerically, mathematically, statistical evidence wise, determine if they're independent. Okay? So then I was asked earlier today, how do I know which one to make the B? How do I know which variable to make the B? And so I think I kind of came up with this to help. Your B is going to be the one that's the because. So because you're a female, is that changing the probability of you being going to Whataburger or whatever it is that the problem's about? Because you're a senior, is that changing the probability you're going to Whataburger? Because you're a female, is it changing the probability you eat breakfast? Whatever. So your kind of like explanatory one is the one that goes here. And then the other one, you're seeing if your overall probability of A and your conditional probability of A change, or are they the same? Okay, so let's take a look over here. When we're talking ag and human ecology, do you think that, which one would you call the because? So I kind of don't know on this one. I think you could go either way on this one. I don't think we have a clear explanatory one on this one. So in that case, I think you could pick either one. So I'm just going to do the first one here. Overall probability of ag, and then overall the probability of ag given that you're in human ecology. So this one was a case where it didn't really have a clear explanatory variable. Now, if we were talking firstborn that and such, that would be one. Okay, so let's do our numbers here. Go look on over to page 27 and see what is that overall probability of ag. So 93 out of 223 is that marginal probability of being in ag. Okay, so we got that, 93 over 223. All right, now let's do this other one. Out of all the human ecology students, so what's that? 43. So out of the 43 human ecology students, who are the human ecology and the ag ones? The ag and ecology. And what do we say? Yeah, look right here. No students are in both. So the intersection is 0. There is no student, there is no intersection, no student in both. So therefore, what's this probability here? 0. So what do we say? The fact that you're in human ecology did what to the probability of you being in ag? It changed it. So the answer is actually, are they independent? And that is no, they are not. So they are independent. Da, da, da. So they not independent. Not independent. And it does say explain. And so we have our statistical evidence over here. And I would say the fact that you're in the ecology department, in this case, it eliminates the probability that you are in agriculture. Okay, so there's your explanation for why that's not independent. And here is that statistical evidence. Okay, so when you are asked about independence, this is what should come to mind. Okay, that's your trigger word. This is what should come to mind. Okay, very good. So I'll let you do the next two parts on your own about the firstborn and whatever else it is. But let's take a look at your homework from last night. Let's just kind of go over a few of those to make sure you're on the right track before I come around stamping you. So do you want to look at like the first one on page, what is it? Page 34. Yep. Let's kind of go over the first one here. Is that okay? Especially since I had y'all do the video yesterday, I want to kind of make sure you're in good shape. Okay, we doing okay? All right. So I want to tell you about, as I was reading this, how this kind of triggered in my mind so that I knew how to organize it. Okay, so here's what happened with me. So I was reading this problem. It says a survey of AHS students, 36 are interested in going to Whataburger. And then I start reading this. of those who wanted to go to Whataburger, 60% are seniors. Of those who did not want to go to Whataburger, 30% are seniors. So that's what I want you to hear as you're reading it. If this, then that. But if this, then this is the probability. So as I was reading it, I heard, if you go to Whataburger, then you have these percentages. But if you don't want Whataburger, then you have these percentages. That means I had two conditional probabilities. So I had, several, if you have several conditional statements. If this, then that. But if this, then that. Oh, but wait, if this, then that. So that's what your brain should hear as you're reading, is that is your trigger to know what's your technique? A tree diagram. I actually first tried to do this one as a table because I thought Whataburger or not, seniors or not, two categorical variables. But then I went, oh, wait, really I should do this. So let's take a look. So I set up my tree diagram where I said, here's all of our students. There's Whataburger and not Whataburger. And then if you're Whataburger, senior versus non-senior. If not Whataburger, then there's your senior versus non-senior, and so on. Okay, so just to make sure we're all on the same page, I want you to take a look at this number right here. 21.6%. So I want somebody to tell somebody something. Let's see. Odds. You're going to tell the evens. What does this 21.6% mean in context of this problem? Okay, so take a moment to figure out what that means. Go. Okay, so let's see how you did. Okay, so odds told the evens. So what'd you come up with evens wise? Hadley, what'd you get? Who's even over there? What you got?
He said that 21.6% of the students that are seniors wanted to go to Whataburger.
Students. Correct. Okay, so 21.6% of all students are seniors who go to Whataburger. See, that's a little bit different than what you said. So 21.6% of all the students. So these are of all the students, those are the 21.6% are this and that. Okay. And whatever that number is, that much percent are non-seniors who go to Whataburger and so on. Okay. So now let's just wanted to make sure you kind of understood that. Let's go on to the question. If a randomly chosen student stopped at the football game is a senior. So this is now that given that. So given that they're a senior, so out of all the ones that are seniors, what's the probability they're going to Whataburger? So here's how this works. We want to say then, so that means given that. So I need to put all of the seniors portions on the bottom. And this, what kind of senior portions are there? There's two of them. The Whataburger seniors or the what? The non-Whataburger seniors. So you're either a Whataburger senior or a non-Whataburger senior. And that's how we get these two numbers on the bottom. So the Whataburger seniors or the non-Whataburger seniors, for a total of 40.8% of them are seniors. Okay, now, and of those seniors, what proportion are the Whataburger seniors? So on top is always going to be one of the pieces that was in the total. So you can count on that whatever this number is here, it's going to be one of the pieces that were combined together for the bottom. Okay, so do know that. And so which piece did we want? The Whataburger piece or the non-Whataburger piece? The Whataburger piece. So that's why the 0.26 is on top. And so there we go. So overall, what is, see, evens? Tell the odds what this 52.9% is saying. In context, go. Okay, so what do we got? Evens. So, and then odds. Okay, so Maddie, let's hear what you say odd-wise. Go.
She said that 52.9% of seniors are going.
There you go. 52.9% of the seniors go to Whataburger. Good. That's correct. Okay, good. So it's out of the seniors. So 52.9% of the seniors. Very good. Okay, so questions there. This one then did go on to ask about independence. So what should you think of when you see that? Dun, 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 dun. This is what better come to mind immediately. Is it independent? Oh, bam, I better write that down. Okay, so that's what I did. And since I already had the Whataburger, given that it's a senior, since I already had this from up above, I just kind of like rewrote that. I don't even know why I rewrote it. I didn't have to show all that work again, but I did. That was my 52.9%. And then I compared it to Whataburger overall to see if the fact that you're a senior changed the rate at which you went to Whataburger. Okay? And see, here is my overall going to Whataburger. The seniors and non-seniors together are 36% of the sample that go to Whataburger. All right. So what do you have to say about that? Oopsie. So 36% go to Whataburger, but if you're a senior, what? 52.9%. So the fact that you're a senior does what? Increases the probability that you're going to go to Whataburger. So independent or not independent? Not. Okay. All right. Questions there. So I'll do one more problem with you before I come around stamping and then let you get to work on stuff. So let's go on over to 36 and 37. Which one of these do you want to do? I'll do one of these four. Which one you want? Claim it. Go. Number four? Number four on Republicans and Democrats? No? Yes? That's what I heard first. Here we go. Okay. So this is just Monte Cristo County. So, yeah, if you're a Republican, then here's the probabilities for money. If you're a Democrat, then here's the probabilities for money. So that's two if-then statements. So I know I got to make a tree map. Okay, so there's my tree map right there. So, this is very interesting. I wonder if socialism plays into this. I don't know. I'm not saying one way or the other, but, you know. Okay. All right. So let's go then answer the question. So here we go. If one person earns, oh wait, hold on a second. If one person who earns over $100,000 is chosen at random, what's the probability that that person is a Republican? So what's that question telling me? Do I have given information or not? Is it just an overall or is it conditional? It is conditional. Conditional upon what? Yeah, how much money you make. Okay, so it's saying given that, right here, given that you earn over $100,000, what's the probability you're a Republican? Okay, that's what that question's saying. So let's see. So what should the denominator be? The denominator should be all the people who do what? Earn over $100,000. Good. And so that would be the Republicans who earn over $100,000 or the Democrats who earn over $100,000. So there's our denominator. The totality of those who earn over $100,000 will be the 0.12 plus 0.0426 or 0.0425, sorry. And that is 0.1625. So I added those together and I get 0.1625. And then remember, this one up here is always a part of the denominator. It's the Republican part of the denominator. So that's the 0.12. I had students who are tempted to put all of the Republicans on the numerator. So did you put 0.15 on the as the numerator? If you put 0.15, then why is that bad? Because it's not just the ones who earned over 100,000, it's all of them. Okay, see, we just need the ones who are the over, we're only in the 100,000, everybody else went in the hall. We're just talking about all the over 100,000 people. Okay, anyway, so there's how you get that. So if you make over $100,000, there's a 73.8% chance you're a Republican. Okie dokie. So there's, and all four of these problems on this assignment mirror this whole thought process, okay? All right, so I'm going to let you get started on that while I come around and stamp you. And shortly, I'm going to have a little discussion with you about the first problem on the warm-up. Some people have struggled with that, but I want you to do it or try it first, and then we'll get back together if there's been a problem. So we'll see. All right, so I want to talk about this first problem on the warm up because it's kind of actually throwing in a problem different than we've ever seen before, but we should be able to deduce what's going on. So let's take a look. So first of all, we know that we've got dogs in the US or dog owners in the US, and so this is total circle here is 39%. So we know the proportion of all dog owners in the United States is 0.39. Okay, but then we also know that do you think dog and cat owners are disjoint or joint? I'm pretty sure they're joint because I imagine there are some owners who have cats and dogs. Okay. And so we know that the probability of a cat, okay, 34% of the nation owns cats. Okay. So the issue is this. If I take this 39% that are dogs, okay, and I add it to the 34% who are cats, then what just happened? So if I added those together, what am I getting? I got some double counting happening in here. Okay. Now, adding these two together is 73%. Okay. So, but I can see adding it together had this double counting. So I got to figure out how much is that double counting. Well, that comes into play whenever we are told this. 60% of the US, so these two things together make up 60% of the United States. So I should add them together, take away the double counted cat and dog owners to equal 60%. Okay, so if that's the case, then what must have been double counted? 13%. Okay, good. So see, you add those together and take away the 13% that got double counted, and that's how you get your 60%. Okay? All right, questions there. So that will get you going. And of course, you know that this is all the owners in the US. So then, you've got some out here that don't own neither a cat nor a dog, and so on. And then we'll talk. So anyway, I'll just leave it at that right there and let you do those. All right. So again, I'm going to keep coming around stamping you, but you'll want to finish this homework here so that we're prepared. We'll go over this warm up and such before our quiz tomorrow.